Hey there. So if you've been following along with my fermentation chamber tutorials, you probably noticed by now that the fermentation controller can only do one thing, and that is to cool the beer while it's fermenting. So that's usually okay, but I have a problem in that in the winter, in the basement where I do most of my fermentation, sometimes in the middle of winter it can get down to like 60 degrees or so in the basement, and that's just too cool for a lot of ales to ferment. So what I really need is a heating circuit. That also opens up a lot more possibilities for me. So maybe you can find a different place in your house that is, around 40 or 50 degrees, like your garage, and it's a lot easier to, say, brew a lager in your garage when it's 40 degrees and you want to raise the temperature up to 50 or 55 or something. Using heating is a lot easier than putting it in a warm part of your house and cooling it down and having to change the ice bottles and all that sort of thing. So basically it increases the flexibility a lot to be able to also heat. So to that end, I'm going to use one of these cool heating mats here, and these just plug into a wall socket, a 110 wall socket, and they provide nice gentle heating if you wrap this thing around your fermenter. So it's not going to like burn up the yeast or anything like that. It's just going to provide nice gentle heat. These are usually sold either as mats that are specific for home brewing, or this particular one is for seed germination. So you can actually like put containers of seeds and soil on top of this thing, and it'll heat it up and get those seeds to germinate. But the exact same thing works really well for keeping your beer at the right temperature. So if we can basically create something that will control the AC power to this mat, then we can put that under software control. So that's what we're going to do next in this tutorial. And to control power to that heat mat, we're going to use a little bit different device than we've used in the past, and we're just going to use an off-the-shelf smart plug. So this happens to be a Sonoff S31, and it is actually running ESPHome as well, but that is not necessary. You can just use really any of hundreds of different smart plugs that are available. These are great because you can get them so cheap. This one I think I got for about $8 on sale, but definitely under $10 is probably a reasonable expectation for this type of device. So really you just plug it into the wall and then plug your device, in our case the heat mat, into the other side, connect it up to HomeAssistant, and that's pretty much it. Now there is one thing to worry about with this, in that we want to make sure that the integration that HomeAssistant uses to talk to this smart plug is a local integration. So let me explain what the difference is between like a local versus cloud integration. This drawing is kind of a direct connection model. This is what we've used in both of our temperature control projects so far. We have an ESPHome device that is connected to a relay, either a bare relay like we used in our fermenter chamber, or one of these IoT relay devices that we used in the quick temperature controller. And then that's directly wired up to a load, and that could be a compressor on a freezer, it could be this heat mat that we're using in this project, or the fan that we used in the fermenter project. It could be just about anything. In this model, the way it works is we have an ESPHome device on our Wi-Fi network. It is directly wired to a relay module, which is directly wired to a load. And so the ESPHome device reads the temperature, decides when to turn on and off the load, to control that temperature. And really the only significant or likely point of failure here is that we could lose power to the ESPHome device. So that's one point of failure. But the ESPHome device does not need to talk to the Home Assistant server, and it does not need an internet connection. So really the only likely thing is if we lose power. Now there are some less likely points of failure, which I'm not going to be mentioning here because they are less likely. So before you jump in the comments and say, hey, you missed a bunch of things, yes, these hardware devices could fail, the relay could fail, any number of things like that could happen. A meteor could fall out of the sky and hit your house. That'll make your device stop working. But I'm really only going to talk about likely points of failure here. All right, so the next thing we're going to talk about is what we're going to use for this project, which is a local connection, which really just means that we don't require the internet for this to work. So it's going to be the same as before, except now there's no direct connection between the ESPHome device and the relay module or the smart plug. So what we do instead is we're going to configure the ESPHome device to talk to the Home Assistant server, which will then communicate to the smart plug device to turn it on and off. So this does introduce some other points of failure. So we still have the problem of, okay, if we lose power, everything goes down. But now, if our Home Assistant server goes down, or if our Wi-Fi network goes down, that could break the system. So we went from one significant point of failure to 3 possible points of failure. But these aren't super likely as long as your Wi-Fi network is good at your house, and the Home Assistant server almost never goes down if you're using something like a Home Assistant Green. So those are still manageable issues. Now, personally, I still would not want to use a smart plug in the case of where I had something that was on all the time, like a Keyser or a kegerator. I would want something more reliable that was directly connected to the ESPHome device to just get rid of these 2 possibilities. But if you're building a fermentation chamber or something that's only being used for short periods of time, I think this is acceptable. But you be the judge for your system. Okay, this is our last scenario, and this is the one that I don't recommend, but let me talk about why. Okay, so in this one, we still have our ESPHome device communicating to our Home Assistant server that's on our local network. But now, because this is a cloud-connected integration, Home Assistant has to talk through the internet to the manufacturer's server. And then that server will send a command back to Home Assistant, and then that gets sent to our smart plug device. Okay, let's talk about points of failure here. Okay, so we still have the problem of losing power. We still have the problem of our Home Assistant server going down or our Wi-Fi going down. But now we also need our internet connection, so that could fail. And then we still have to talk to the manufacturer server. So that could go offline just because servers on the internet sometimes fail. Or also, this happens surprisingly frequently, the manufacturer could go out of business, and then you're kind of done forever with that smart plug. So any of these things could happen. So now let's recap a little bit. For the direct connection method, we had 1 point of failure. For the locally connected smart plug, we had 3 points of failure. For the manufacturers, or for the cloud connection method, we added 3 more. So that's 6 points of failure, of likely failure. And I think that's just unrealistic, and we shouldn't do that. So next up, let's talk about how you check to see if the Home Assistant integration that you're using is a local integration and can do local control, or it actually requires the cloud to do its work. The best way to do that is to go to the Home Assistant website, which is just at homeassistant.io. You should see that URL on the screen now. So this is the page. We're going to click on the integrations link. And now this is just a searchable kind of database of all the integrations that Home Assistant has available, which are just kind of plugins to Home Assistant that allow it to talk to different devices or services. So let's start off with TP-Link. So I'm just typing in TP in there. I'm going to go to this TP-Link Smart Home. So I have several TP-Link smart plugs in my house. They work pretty well. I'm pretty happy with them. And okay, so up here in the upper left kind of area of this integration page, it gives you all sorts of information about this integration. But the part that we really care about is this, where it says the IoT class of this integration is local polling. So the word local there is key. You can actually click on that and it will take you to a page that just describes what local polling means. And it also mentions the two cloud methods that we want to avoid. So local polling in our case is great. So this TP-Link integration would work just fine for our purposes. Okay, now let's back up and let's do a different integration. So I'm going to type in Tuya. Now Tuya, these devices usually aren't actually called Tuya brand devices. They come under a ton of different brands, but the key part here is that they typically use the Smart Life app on your phone to control them and register them and that sort of thing. So there's a ton of smart plug devices that actually use this Tuya integration. So now this one, we check its IoT class, and it is a cloud integration. So this is cloud push. So basically, if you see cloud here, that is bad. That uses that cloud scenario that we just talked about. And we want to avoid devices that use integrations that are tied to the cloud. So if you have a Smart Life smart plug, probably you should use something else, a different device that uses the local mode. Okay, so now let's examine what kind of changes we need to make to the YAML file to support this new heating mode. So I've modified my Fermenter 1 with its clever name. So note that in the description, we'll have links to documentation for this project. There will be two YAML files available, one with the original one, which just does cooling, and then there'll be an additional YAML file that will have cooling and heating. So it's basically the file that we're looking at right now. So the first major thing is I've added another entry under our switch mode. Let me zoom in on this a little bit. Okay, so I've added a new entry to the switch section of the file, and the type is Home Assistant. So basically what this is doing is it's saying, hey, let's import an already existing switch item from Home Assistant and let's use it as if it was a switch device that was defined in our YAML file. So the only thing we really need to give it, other than telling it, hey, the platform we're using is Home Assistant, is we need to give it an entity ID. So this is the ID that Home Assistant itself uses to identify this switch. So I think it'll always start with switch dot and then some name. So let me show you now how to find that entity ID. So let's go back to our main dashboard in Home Assistant. And we want to find the relay device for that smart plug. In my case, it's this plug one relay device. I don't know if it'll always be called relay, but it is the device. You can toggle it here, toggle the power state on and off and check. but mine is called plug one relay. So once you find it on your dashboard, click the name, not the little toggle switch, and then in the dialog that shows up, we're going to go to the gear icon, and then right here in a field called entity ID is the actual string that you'll need to add to your ESPHome YAML file. And there's even a convenient copy button, so we can just hit the copy button and that'll copy it to our clipboard, and then we can navigate out of this dialog and go back to ESPHome. Okay, so now that we have the entity ID, you can just copy and paste it here in the entity ID field. And then we're also going to give this an ID that we'll use later on in the thermostat here in a moment. So this can be really any name. Just for me, it made sense to call it heater power, but call it whatever you want. So now that we have our switch imported into the YAML file, let's go ahead and modify the thermostat to use the heat. Okay, so there's a few modifications here. The first thing we did is we changed the mode from cool to heat_cool. So that basically just says, hey, now it's capable of both heating and cooling. Also, I added an entry here for default target temperature high. So basically there's going to be two set points now for this thermostat. There's going to be like a heating set point and a cooling set point. And if you think about it, the thermostat in your house probably has the same thing, where depending on whether it's in heating mode or cooling mode, it has two separate temperatures that it keeps track of. So this is really no different than that. So we're adding a new entry here. This is just going to be kind of the default value for the heating, it's this one, the low temperature that we've added. So this is going to be the default value for the heat set point. Sorry, I messed that up there. Okay, then the other thing is we're adding two new entries. So before we had the min cooling off time and run time. Well, now we're going to have the heating equivalent of that. So we're going to have a minimum heating off time and a minimum heating run time. This just means it will, when you turn it off, it'll be off for at least 30 seconds. And when you turn it on, it'll be on for at least 30 seconds. With this heat wrap that we're using, there's really no point in, turning it on for less than 30 seconds. In fact, you could probably even up this to like a minute or something like that. So we just don't want to be switching it on and off too fast. It probably won't hurt it, but it also there's not much point to it. I also increase the idle time to 30 seconds as well. Then, let's see, we also have to tell it what to do, tell the thermostat what to do when it wants to turn on the heat. So basically we add this heat action entry, and then we can do one or more items underneath that. In this case, we just want it to turn on the heater power switch that we added above. So that's our smart plug. And then we'll also add, we already had an idle action, but we need to tell it to turn the heater off in the idle action. So we're adding a new entry here, the switch.turnoff heater power. Again, that's our smart plug. And that's the only modifications that are required. Okay, now before we're finished, there's one more step that we have to do to make sure this integration with the smart plug will work. So let's navigate to the settings panel in HomeAssistant, and we're going to go to devices and services. And then we're going to scroll down and we're going to find our ESPHome add-on and just click on that. And here we're going to see a list of all of our devices. And what we want to do is find our fermenter or temperature controller device. And we're going to click on the little gear icon and it'll pop up this dialog. And what we want to do is check the allow the device to perform HomeAssistant actions. So this is basically a security feature of HomeAssistant where it won't let your ESPHome device go in and control other HomeAssistant devices unless you check this box. So this is basically just a box to make sure like just a check and balance, that you know what you're doing and you want this ESPHome device to control another Home Assistant device. So we're going to check that box, and then we're going to hit the submit button, and it'll say, okay, successfully saved, and we can hit finish, and we're done. Except in my case, I want to, my smart plug device is actually running ESPHome as well. So I need to do the exact same thing for mine. Check that box again, hit submit, and then finish. You only need to do this if your smart plug itself is running ESPHome. So if you're using like a TP-Link smart plug or something like that, you don't need to do this step. Okay, installation for this heating device is really easy. So this is the power strip that I use for all the little power supplies and stuff that I need for my fermenter. And so I just plugged our smart plug into one of the open spots, and then I plugged the fermentation wrap into the smart plug. And then on the other side of the fermenter, you can see I have the heating mat wrapped around the fermenter, and then I just use bungee cords to just keep it in place. That seems to work well. And that's it. Now, with all that work done, let's take a look at how we actually use this new thermostat. So this is my dashboard for the Fermenter 1, where I just added the heating circuit. You'll notice there are two set point kind of sliders here. So this one is the heat, and basically the lower one is the heat, and this one is the cooling set point. It's pretty warm right now in my basement where this fermenter is because it's the summer. So we're just going to pretend that we want to set these higher than we normally would for our fermentation, just to demonstrate. So what I'm going to do is I'm going to set the heat set point to above 70 degrees so that this will actually turn on. And then you'll notice here that there's additional buttons. So it used to just be an off button and a snowflake or cooling button. So now we have new ones. Now we have a flame button, which is to turn heat on, and there's another one that is basically a heating cooling mode. So basically this one will try to keep the set point in between the, it will try to keep the temperature of the fermenter in between the two set points, and it'll heat or cool to keep it in the middle there. Usually I just set it to either heating or cooling because I know it's only going to need one or the other, but you could be kind of in a weird place where the temperature of wherever you're fermenting is kind of in the middle and you don't know whether it might need heat or cool. So, well, you can use this button and it'll automatically do the right thing. But for demonstration purposes right now, let's go ahead and just turn on the heat mode. And you can see the set point is higher than the current temperature of 70 degrees. So it started to heat and it turned on power to the plug automatically. So now let's adjust that temperature down, the set point below the heating, or below the current temperature. So it's set to 67 degrees. Now you notice it hasn't turned off right away. And that's because we have a minimum on time of 30 seconds. Oh, there, it just flipped off. So it basically wouldn't turn it off until it had gone at least 30 seconds. And that's because we set that minimum heating on time, I believe was the parameter in the YAML file, to 30 seconds. So you'll notice you saw that in play right there. So now it's set to heat mode. So if that temperature were to drop below 67 degrees, it'll turn on the heat and boost it back up. So that's pretty much it for how you operate this. So thanks for watching this tutorial. I hope it was helpful. Subscribe to the channel to see more content like this. And let me know if you have feedback or questions in the comments to the video.